Hello, everybody. So welcome and have a seat here in the auditorium as we have our Directors Awards for this year. Good afternoon and thank you for being here today. I want to extend a special welcome to the friends and families of our awardees. The Berkeley Lab Directors Achievement Award ceremony is really a special occasion for us. We feel extremely fortunate to be able to work at this great laboratory in the surface of the nation as we pursue scientific solutions to some of the most pressing problems of our time and work to create a better future. This mission is even more important this year. This work cannot be done without really inspired people. The most impressive thing that I've learned about the lab is that one finds such enormously talented people in every division, department, and group at the lab. Today, we're going to honor some of those who contribute to the lab by creating a great, diverse, and inclusive culture, by helping the operations function efficiently and effectively, by advancing technology, and of course, by contributing to our great science. This work would not be possible without the dedication and commitment of outstanding individuals here at the lab, and there are many dimensions to this effort. We're here today to honor these achievements. So we're going to do this with a series of videos for our Lifetime Achievement and Berkeley Lab Citation awardees. I think you'll enjoy these to highlight their accomplishments. And so I'm going to start our presentation today with our first Lifetime Achievement Award. I'd like to introduce the work of beamline scientist Alistair Mcdowell. Throughout his decades-long career at the Advanced Light Source, Alistair has made important contributions to light source instrumentation, many of which have enabled scientific breakthroughs. So let's take a look at the video.
Alistair is a remarkably eclectic intellect, and he is able to look at literature from a widely disparate area and identify areas where his expertise can have a profound impact.
I was always inquisitive about how things worked. I remember pulling things apart as a teenager just to find out how they worked. My grandparents didn't like me for doing that. So I ended up doing a postdoc which involved fluorescence spectroscopy, which required using synchrotron, which was a government laboratory built in the middle of nowhere. And I showed up there just as they were getting going. It was great fun, I found, just trying to make the thing work. We started getting some international people over. Some of them were from Bell Labs in New Jersey. Bell Labs was going to build new beamlines at the Brookhaven storage ring, and they needed help. So I thought that'd be quite good, fun and interesting to sort of work there. So I was the Bell Labs frontman at Brookhaven, sort of dealing with various Bell Labs beamlines, and one of them was EUV lithography. But there was a group of us who actually did the first experiments to print 500 nanometer lines and spaces with EUV light using diffraction limited multi-layer coated optics. And that demonstrated that the physics actually worked and you could actually implement the physics. This was a demonstration experiment in 1989, but it was only until 30 years later that the technology was actually available. First light in the ALS was in 1993, but there was nothing on the experimental floor. When I showed up in 96, the aim was to build new beamlines and bring new users in.
What he did for the microtomography beamline was miraculous, quite frankly. I got a big program with Teledyne to look at these new modern ceramic composites. And we wanted to understand how they fracture. These materials can operate at 1700 degrees centigrade. I suggested to Alistair that maybe we could build some kind of furnace that goes into the beamline with a testing machine on it. And I thought that was completely mission impossible. And he said, fine, we'll look into it. And within maybe half a year, they built something. And so we tried it, and it virtually worked first time. And we got the front cover of Nature Materials for this. And it was just a really spectacular achievement on his behalf. And it enabled us to do some really super work.
He brings a lot of different skills to bear, not only the skills of a first-tier experimental scientist, a synchrotron expert, but also he brings a engineering ability to just do things. And in tandem with that is his preternatural calm and relentlessly dry humor that he employs throughout any exercise he does at any facility.
The aim is to try to make a difference. I don't know whether I have done or not, perhaps a little, but anyway, that's what I've tried to do anyway.
Terrific. Thanks for that work on that great video. And Alistair, would you like to step up and make a few brief remarks?
Well, thank you for the award. I must admit, I've felt privileged to sort of had a career in science for the last sort of 40 plus years. As you see, I've been employed in various institutions around the world, starting in the UK, Berkeley Lab, Brookhaven, and now for the last 20 plus years at the ALS at Lawrence Berkeley Lab. And it's been fun here, sort of building up new beamlines to do the new science that keeps the ALS at the forefront. So I thank you very much for sort of working with everybody here. I feel privileged. I hope I've made a difference. Thanks again for the award.
So congratulations, Alistair, and thanks so much for all you've done for the lab. Our next presenter, Susanna Trench.
Thanks so much, Mike. This next category recognizes significant scientific or technical contributions leading to important progress in an area of research or completion of a project for staff who are at or near the beginning of their career, the early career awards. Our first awardee is Emily Ilo Fedroche. And as her nominator Axel Wiesel wrote, Dr. Ilo Fedroche has emerged as a rising star in the relatively young field of microbiome data science. Emily is the program lead for the National Microbiome Data Collaborative and provided outstanding leadership when it was established as a $10 million multi-lab effort in 2019. The NMDC is enabling a global community of researchers to advance energy and environmental microbial genome science. One colleague noted that Emily is the rare individual who was a highly regarded research scientist, yet who is willing to sacrifice a small measure of her personal research interests to guide the development of a crucial scientific resource for the community. In addition to the NMDC, Emily provides valuable scientific expertise as the head of the metagenome program at JGI. As lead of the environmental genomics group, she has built a highly successful research program and has published high quality, influential papers that are at the top of her field. In addition to noting that she is a force in microbiology, one colleague commented on her impact on the community, saying, "I draw inspiration from Emily, her intellect, patience, and work ethic, and some of my female students who don't even know her personally draw strength from her leadership as a woman in science." Emily, could you join me on the virtual stage? Please join me in congratulating Emily on her outstanding achievements. So this next early career award is for Chris Mungle. Chris is a world leader in the field of gene ontologies, a computational way to represent the relationships between biological systems. He is best known for his leadership role in the Gene Ontology Project, or GO, which has produced algorithms and software that are used in everything from crop breeding to disease classification, and is one of the most popular biological resources today. Chris's paper on the GO resource has been cited more than 5,000 times. Chris is involved in several other large collaborative efforts, most notably the Monarch Initiative, ENVO, and Alliance Genome. He also plays a significant role in the NMDC as co-lead of the metadata group. His computational and AI background enable him to bring a unique perspective to his collaborative work and contribute to his leadership in bioinformatics and semantic engineering. Finally, Chris was part of Berkeley Lab's response to the global pandemic. He led the development of the KG COVID-19 knowledge graph that supports machine learning and other analytic approaches to discover new associations in COVID-19 related data. This approach will maximize discovery and prioritize critical clinical studies as quickly as possible. As one colleague noted, this rapid and efficient pivot of Chris's expertise toward addressing COVID-19 is not only greatly valued, it is exceptional. Chris, could you join me on the virtual stage? Please join me in congratulating Chris on his outstanding achievements. And now let me turn it over to the next presenter, who is Jeff Neaton.
Thanks, Susanna. So it's a real pleasure to present this next Early Career Directors Award to Peter Agbo in the Chemical Sciences Division. While Peter was still a postdoc in Rebecca Abergel's lab, he successfully demonstrated the promise of ligand-sensitized down-conversion nanoparticles doped with F elements for harvesting high-energy photons from the solar spectrum. This work initiated a number of new directions in the photophysics of these nanocrystals, doped with rare earths that are still active today, and has generated a lot of interest. And this work he did as a postdoc at Berkeley Lab led to him being recognized with an Early Career LDRD Award in the energy sciences area in the inaugural 2018 class. Now a PI in the Chemical Sciences Division and a staff scientist in the Liquid Sunlight Alliance, formerly the Joint Center of Artificial Photosynthesis, he's developing prototype testbed devices for harvesting light at lower wavelengths for solar fuel generation. One colleague noted it's rare to find a researcher that spans such a scope from basic science to applied integration and device operation. In true Berkeley Lab fashion, Peter's success comes from his ability to use his understanding of both biology and inorganic chemistry to inform his work. He operates fluidly at the nexus of these disciplines. He combines his previous experiences to yield unique concepts from biological systems that can be enacted in inorganic solar fuels. As his nominator, Kevin Wilson, wrote, Peter's research and achievements are a tribute to his creativity and demonstrate his ability to establish entirely new directions within photochemistry and biochemistry, areas of importance to the lab's BES portfolio and beyond. One such new direction at a nascent but promising stage is Peter's efforts to explore new avenues for economical CO2 conversion using biomimetic platforms and enzyme-mediated catalysis. This study will certainly be among Peter's string of successes. For as one colleague wrote, once he has answered his initial questions, Peter does not just pursue incremental explorations, but seeks to make leaps in new directions from the knowledge foundation he has created. Peter, please join me, everyone, in congratulating Peter on his outstanding achievements and on receiving this award. Peter, actually, could you start your video? I think I was supposed to do that before saying that, but Peter, congratulations on this award. And now it's my pleasure to introduce Susan Hubbard.
Thank you, Jeff. Good afternoon. It's a real pleasure that I have today to present the final Early Career Directors recognition for this year. Like Peter Agbo, Charu Varadarajan has also mastered multiple fields to advance science and to foster multidisciplinary teams. Charu's a hydrobiogeochemist with extensive field and laboratory experience. She's also a data scientist and a statistical modeler. Her wide-ranging scientific expertise, combined with her capacity to build scientific communities around a collective vision that adheres to fair data practices, has enabled environmental systems scientists to more effectively archive, share, and utilize diverse data and to solve complex water resource and environmental problems. Her nominator, Deb Agarwal, writes that Charu is one of the few people worldwide who can so seamlessly work across and connect earth and data sciences. She's already made substantial contributions, and she's provided critical thought leadership regarding environmental and data research directions and their intersections. Charu is known as a force for team science. She plays leadership roles on several signature DOE BER projects. For example, she serves as the Deputy Director of the ESS Dive Data Repository. She leads the data management teams for both the Watershed Function Scientific Focus Area and the NG Tropics Project. She's the chair of DOE's Cyber Infrastructure Working Group for Data Management. And we're thrilled that she's a recent recipient of the DOE BER Early Career Research Program for Environmental Science Project. Environmental data science is an emerging growth area in DOE BER. And Charu has established herself as a recognized leader already in this discipline. As one of her supporters wrote, she's been able to leverage the insights and skills of a process scientist, a data scientist, and a community builder to establish an important and rather unique niche for herself at Berkeley Lab, within the DOE, and within the broader environmental science community. Charu, could you please join us on the virtual stage? Thanks, Charu. Everyone, please welcome me in congratulating Charu on her impressive achievements. Thank you, Charu. Next, I'd like to present an award for Carl Stiefel, who's recognized this year for scientific achievement. Carl has made groundbreaking and substantial contributions in understanding Earth processes at the intersection of geochemistry, which is his primary field, and biogeochemistry, hydrology, and geology. Carl's deep and unusual combination of theoretical, experimental, and computational expertise sets him apart from most, if not all, geochemists in this field. And it's uniquely enabled him to address cutting-edge scientific and engineering questions that are relevant to many of DOE's environmental and energy challenges. Carl has pioneered the development of reactive transport modeling software for earth sciences called CrunchFlow, which is arguably the top performing software for multi-component reactive transport in the world. His work has been instrumental in introducing reactive transport modeling to the mainstream geochemical community. First developed in the early 1990s, CrunchFlow has continued to evolve and in fact won an R&D 100 award in 2017. But Carl moves on. He's continued to advance computational earth sciences approaches. He's the PI on only one of 2 subsurface exascale projects in the world, and he's the PI on the world's first systematic AI for watershed framework. One colleague and letter writer wrote that Carl Stiefel has arguably done more than anyone in the world to introduce reactive transport modeling as a research discipline and as an approach to the geochemical and broader hydrological community. In addition to his computational contributions, Carl's had substantial and sustained scientific impacts on a wide range of studies. He's always pushing the boundaries of using computational tools and theory to understand complex, multi-scale, multi-phase coupled Earth system processes. He contributes to a variety of new insights, illuminating, for example, the origins of scale-dependent discrepancy of reaction rates that's plagued the geochemical community for decades. Based on his scientific contributions, Carl was recognized last year as an AGU Fellow. Carl, can you please join me on the virtual stage? Thanks, Carl. And now I'd like to ask everybody to join me in congratulating Carl on his impressive achievements. Thank you, Carl. I'd like to hand the floor over now to the next presenter, Mark Levine.
Thank you very much, Susan. Good afternoon. I am Mark Levine, founder of the Lab's China Energy Group. It's a great honor and privilege to introduce the next Lifetime Achievement awardee, my colleague and good friend, Lynn Price. Over her 25-year career at the lab, which included 59 trips to China, she created robust partnerships that successfully reduced energy use in the country's vast industrial sector. How vast? The energy use in China's industry is responsible for more greenhouse CO2 emissions than the entire emissions of the United States. And Lynn played a key role in reducing those emissions. The video that you're about to see touches on some of her significant achievements to energy efficiency policy and practices around the world, and especially in China. Lynn, congratulations.
It seemed to me that China's industrial sector was a growing area where you could have a very large impact if you could introduce some methodologies for analysis or some technologies or policies that would help to reduce or improve the efficiency and reduce the emissions from that sector. Soon after I started working with Art Rosenfeld, I also started working with Lee Schipper. And then when I was working with them, I met Mark Levine. And that was a real turning point in my career. Of course, he founded the China Energy Group in 1988.
She took on a challenge to work to improve industrial energy efficiency policy in China. That's a huge challenge because not only is China responsible for almost 30% of global emissions, but 60% of that is due to industrial energy use. She chose to attack the single most significant source of greenhouse gases in the world.
In 2000, we started a pilot program to investigate an energy efficiency improvement target. So we picked 2 steel mills in Shandong province. We had been there to do the inspections of the plant and do all the modeling and the benchmarkings. Then in 2006, the Chinese government decided to expand it to the 1,000 largest industrial enterprises in China. And that was the beginning of the Top 1,000 program. Those plants covered 1/3 of total China energy use. So it was important to make sure that it was a robust program. And we actually developed another benchmarking tool for the cement industry, and we benchmarked 42 cement plants, and we added CO2 to that tool. So the Top 1,000 program was quite successful.
The 1,000 Enterprise Program, after it had been implemented, The Economist magazine called it the most successful energy efficiency program in the world. I mean, it was a huge, huge achievement.
One of her deep areas of expertise is in industrial technology across a variety of industrial sectors, where you could get efficiency changes by modifying processes. These require both an understanding of the engineering, chemistry, and an understanding of both the legal and economic systems, but then it also required an understanding of a wholly different culture and a structure in which those systems operated, quite unique from that United States.
I started the IPCC because of the lab's expertise on building energy use and the lab's expertise just on technologies and policies from an end use perspective. In 2007, the IPCC authors won the Nobel Prize. It was a very exciting time. The work that we did to support the Paris Agreement was based on 3 years of research we had been doing beforehand in collaboration with the Chinese.
There are not that many people who got the relationships, who created that kind of deep understanding at a technical level that can solidly inform US decisions, and conversely, can solidly inform China about US interests. Then it's one of those rare people who's done both.
There's no project that I did alone. Being able to work in an environment where collaboration and team science is supported and really the way that is seen as normal really made success easier and made it more enjoyable too.
Hi, Lynn. I wonder if you could come up and give some brief remarks.
Hi, Mark. Thank you very much. Thank you, and thank you, Director Witherall and others. I was really surprised and humbled to receive this award. It's been a great privilege to work at Berkeley Lab over the past 30 years. I was very fortunate to start working with Art Rosenfeld, and then especially with Mark Levine and the wonderful members of the China Energy Group. I'd like to recognize the support of all the people at the lab that brought their expertise or otherwise supported our projects. All of our funders and collaborators around the world, you know who you are out there. Thank you. Thank you for coming and helping. On the personal side, I'm very thankful for the support of my family, my mom, my sisters and their families, my kids who had the disadvantages, but also the advantages of having a busy traveling mother. And also finally, my husband, John, who supported and accompanied me on this journey. I couldn't have done it without him. Special thanks go out to Nan Zhou, who generously gave her time and expertise and accompanied me on many trips to China and helped to ensure the success of this work. There's a lot more work to do regarding clean energy and climate change in the next 30 years, so I encourage everyone to embrace the lab's team science culture and work diligently to bring science solutions to the world. Thank you very much.
Thank you, Lynn. And now let me turn it over to the next presenter, Eva Nogales.
Nominator Peter Bluford writes that Bob Glaser has dedicated his 55 years career to the research, development, and application of cryogenic electron microscopy, cryo-EM, to the life sciences. This year, we are honoring Bob with a Tech Transfer Award, which is a small token of our appreciation for Bob's decades of continuous contributions. Over the last 20 years, Bob has focused especially on solving two major problems in cryo-EM: the unreliability of sample preparation and the failure to achieve the maximum theoretical phase contrast in the imaging process. His work has attracted the interest of world-leading companies, including FEI, Gatan, and Thermo Fisher Scientific. He's filed 5 patent applications in the last 5 years, though those do not cover all of his prolific inventions on behalf of cryo-EM. As one of his colleagues wrote, there is no one else who has worked as consistently, as hard, or as successfully in transferring cutting-edge, Nobel-winning technology to industry. Bob has been called the father of cryo-EM. He was cited 5 times by the Nobel Committee when they announced the 2017 prize in chemistry for the development of cryo-EM. He is an international reference point for physical and technical understanding of electron diffraction and imaging. He has worked to hone and shepherd cryo-EM, which today is considered to be among the most exciting and revolutionizing methodologies in molecular biology. We congratulate Bob on this impressive and sustained contribution over more than 5 decades. Bob, can you please join me on this virtual stage? And now let me turn it over to the next presenter, Ravi Prasher.
Thank you, Eva. So I am here to present the next Tech Transfer Award. The energy technologies area has dedicated many of its best researchers to the changing the energy use of building sector. Part of our strategy has been to develop relationships with industry, including one that's allowed us to take a proprietary energy analysis tool and use it to create an open source version for public use. We are celebrating the success of this tool today, called the Building Efficiency Targeting Tool for Energy Retrofits, or BETTER. BETTER represents the next generation in remote building and portfolio energy analysis. It has been piloted by nearly a dozen organizations and has helped them identify the best opportunities for improving building energy efficiency. The organizations who have piloted BETTER rave about how it helps them to identify energy efficiency improvements, yielding potentially significant savings. One company wrote, "The BETTER tool has allowed us to analyze sites quickly to prioritize them for further study." Another said that this technology provides us with free, fast, and rigorous analysis to improve efficiency in our schools, all without setting a foot in a building or hiring a contractor. I would like to invite Chao Ding, Han Li, Zulu, Carolyn Zoom, and Nan Zhao on the virtual stage. And please join me in congratulating the BETTER team on this impressive tech transfer achievement. And once again, congratulations team. And now let me turn it over to our next presenter, Natalie Rowe.
Good afternoon. The next set of awards is given by the Department of Energy for outstanding early career research proposals. This year, 76 recipients were selected, including 26 from DOE's national laboratories. We were very fortunate to have 6 early career awardees affiliated with Berkeley Lab as either staff or faculty scientists among this esteemed group. Laura Lammers is a faculty scientist in the Energy Geosciences Division and an assistant professor in UC Berkeley's Department of Environmental Science, Policy and Management. Simon Rue is a research scientist in the Joint Genome Institute. Hong Zhu is a research scientist in the Accelerator Technology and Applied Physics Division. Kwabena Bediako is a faculty scientist in the Chemical Sciences Division and a UC Berkeley Assistant Professor of Chemistry. Heather Gray is a faculty scientist in the Physics Division and a UC Berkeley Assistant Professor of Physics. And Trevor Keenan is a faculty scientist in the Climate and Ecosystem Sciences Division and UC Berkeley Assistant Professor in Environmental Science, Policy and Management. All 6 awardees, please turn on your videos. Join me on the virtual stage. And everyone, please join me in a warm round of congratulations for their impressive achievements. Congratulations again, everyone. And now let me turn it over to the next presenter, Nigel Mounsey.
Great. Thank you, Natalie. It's my pleasure to present the first of 2 Operations Awards. And each year, the Operations Awards demonstrate the absolute critical importance of operations staff to ensure our scientific facilities are well maintained with minimal operational impacts. And this year, we honor such a team again for an even more complex and impressive achievement. The IGB, Move and Transition team exhibited tremendous leadership, planning and execution to transition the JGI and K-base teams successfully to the Integrated Genomics building on the Berkeley Lab campus. And then if that wasn't enough, they led the completed restoration of the Walnut Creek facility on a very aggressive schedule. As one colleague wrote, the team considered every research need with backup plans. The team also put in place a sophisticated and thorough onboarding process. And thanks to the efforts of this team, we completed the move and we were up and operating within 2 weeks, which was about 4 weeks ahead of the original schedule. This team's accomplishment is now being hailed as a best practice across the lab, and I predict will offer critical guidance in our construction of the lab of the future. So Lisa, Don, and Christine, please join me on the virtual stage. And everyone, please join me in congratulating Lisa Kegg, Don Millett, and Christine Nacker for this exceptional achievement. And now let me turn it over to the next presenter, Jonathan Carter.
So it's my pleasure to present the first of the 2 Berkeley Lab Citation Awards, and this one goes to my longtime colleague in computing sciences, Deb Agarwal. We'll show a video that will talk about her many accomplishments in team science in a moment, but I want to briefly mention just a few of her other achievements. In the late 90s, Deb served as an expert to the Comprehensive Test Ban Treaty Organization at the United Nations in Vienna, developing methods of robustly transmitting data from a network of global monitoring stations. As a strong advocate for diversity and inclusion of women and minorities and mentoring of next generation of scientists, Deb received the Director's Award for Exceptional Achievement in 2015 for her work in support of diversity at the lab. She also led her department through a comprehensive reorganization and refocusing of efforts in the mid-2000s that revitalized the research of the department, created a network of science-focused partnerships, and built a strong team, expanding their expertise to all manner of scientific data wrangling and user experience. I could go on, but let me show you the video instead.
My father was a researcher and then head of a research lab at General Motors. And I always loved going to the open houses at the research labs and seeing all the amazing advances they were working on. And it inspired me to think about a PhD as an opportunity to get involved in things that could help change the world and build new technologies. About 2 years from graduation at UC Santa Barbara, I ended up doing an internship with Van Jacobson's group. Van was an internet pioneer. Sally Floyd, who worked with him, was also another internet pioneer. Steve McCann, Vern Paxson. It was a who's who of people in the internet. And it was just this phenomenal experience. 4 years after I started at the lab, I was invited to CRAW, which is the Computing Research Association Committee on the Status of Women. They hold mentoring workshops. I was invited to one of these as a speaker. So I started thinking, what can I do that's going to be the most impactful back at Berkeley Lab? My focus was really around changing the experience for women in computing careers, that they have an opportunity to get the sort of mentoring that I'd picked up along the way through intentional programs. Relatively early in my career, we all realized what we would really rather be doing is having more impact on the science and being part of the team science that the lab is all about. And so we started to really work with the scientists on their problems and bring our computer science capabilities to those problems.
She understood very early that digital science was going to transform other sciences and many application sectors. It was essential for computer scientists to closely work with scientists from other domains, because this was the way to identify the future challenges for us as computer scientists.
Deb felt very strongly at that time that the common paradigm, which was build a data system and users will come, wasn't working. Deb really convinced us that we needed to take this user-centric approach. That was revolutionary for our field at that time. Deb has just continued on to take this user-centric approach in a way that has really transformed not just hydrologic sciences, but much more broadly environmental sciences. She's recognized as just a pioneer in this field, and it's led to all kinds of new scientific discoveries.
That work with your scientists led to a whole new set of CS research topics. It's been the most fun I've had in my career because it's been this opportunity to really impact the science and to build things that are enabling new science to occur.
I want to invite Deb up on the virtual stage to make a few remarks.
Thanks so much, Jonathan, and thank you everybody for the award. It's a real honor. I really appreciate it. It's been a pleasure working with all the people, all the coworkers that I've had, and on all the teams. That's what's made it fun to be at Berkeley Lab, is really being able to work on these teams with researchers from across the spectrum and get to know their science and be able to help solve these kind of world problems. So I really appreciate it, and thank you so much. And thanks also to my family.
And congratulations again, Deb. And now let me turn it back to Nigel Mounsey.
Okay, well, it's my pleasure to present now the Director's Award for Exceptional Outreach Achievement. And this award recognizes significant efforts to further develop and/or improve the lab's community relations, or to promote the lab and/or our education mission. And it's my pleasure to present this year's Outreach Award to the JGI podcast team. So this year's global pandemic has challenged us to find new ways to connect with our users at JGI. Unfortunately, Masi Ballon, Alison Takamura, and Dan Woodward were more than up to the task. In just 6 months, they wrote, hosted, produced, and launched 2 podcast series, The Genome Insider, that covers all things JGI, and The Natural Podcast, that discusses our work and that of the scientific community in natural products. And as one colleague wrote, creating one successful podcast is different. Launching 2 at once is really a Herculean task. and each episode serves to document the diversity of voices and success stories of JGI users and teams. Another colleague wrote that the podcasts have elevated the voices from our community and helped to build new research alliances across institutions. Taken as a whole, both podcasts help to promote the lab service to the public and the extremely valuable contributions of our researchers, support staff, and facilities to advancing scientific innovation. So Massey, Alison, and Dan, please join me on the virtual stage. And everybody, please join me in congratulating Massey Ballum, Alison Takamura, and Dan Woodward for this impressive achievement. Okay, I'm going to hand over to myself to present the first of three Exceptional Service Achievement Awards. And the first of these awards goes to a remarkable scientist who has been responsible for a wide range of JGI's ever-evolving capabilities and technologies. Jianfang Cheng, a 30-year veteran of the JGI, was there at the very beginning, providing major contributions to the Human Genome Project. Later, he focused on building new genomic capabilities, spearheading efforts to build world-class single-cell genomic and DNA synthesis platforms. His work has enabled a large-scale exploration of microbial dark matter, and thanks to him, JGI users can now screen and characterize biosynthetic gene clusters. JGI's Deputy Director for Science Programs, Axel Wiesel, wrote how Dr. Cheng established a springboard for users for taking advantage of the most cutting-edge genomic approaches available at any time. And former JGI Director Eddie Rubin noted, "What makes Dr. Cheng's work so special is how it all happens behind the scenes. He's driven by helping others to be successful." And finally, as his nominator, Len Panacchio, noted, "There's no doubt that tens of thousands of scientists' discoveries are based on the primary utilization of Dr. Cheng's developed capabilities." So Jianfang, please join me on the virtual stage. And everybody, please join me in congratulating Jianfang Cheng for his impressive scientific contributions. Okay, now let me turn over to the next presenters, Michelle Lee and Michael Brandt.
So this award is for service to our laboratory. Probably speak for all of us when I say that this past year it's been extremely challenging for us. Mike, Horst, and I frequently comment on how proud we are of our team's dedication and resilience. This award is given in the context of this past year, beginning in October of 2019 with the first of two public safety power shutoffs, to then moving to the impact of the global pandemic on the lab's workforce, and then ultimately to changes in federal policy. The common denominator in all of these events is our HR policy, and Wade Crossan has been in the middle of leading these changes in our policy to help all of us. Wade serves as the Senior Manager for HR Shared Services, Assurance, and Compliance. In this role, he interprets, guides, and activates the lab's HR policies. When people were unable to work during the PSPS events, Wade led the activation of an emergency paid leave policy so that employees could continue to receive their salary. During the early stages of shelter in place, he quickly modified telework arrangements so we could all continue to meet the laboratory's mission by working from home. He crafted paid administrative leave guidelines for those who were juggling family care and work, even as congressional legislation was in the process of being developed. These are just a few of the monumental tasks Wade has successfully accomplished over the past 12 months. And he has done an incredible job with his day job, which in this past year, not just being a senior manager, but also successfully managing the implementation of the UC Path project, which is a new portal for our benefits programs at the laboratory. And through it all, Wade has demonstrated outstanding leadership, care and support for his colleagues, and the utmost commitment to the lab's mission. From my perspective, this has been truly grace under pressure and a highly visible position. So please join me in congratulating Wade Crossan for his impressive contributions to the support of all of us, to the support of our lab's mission and our workforce. Wade, please join me on the virtual stage. So thank you again for all of your contributions, Wade. And now I'd like to turn the floor over to Michelle Lee, who will present the next award.
Thank you, Michael. The International Research and Scholars Office also had an interesting year. IRSO's primary function is to help hiring managers across the lab to understand and navigate U.S. immigration policies and visa applications. The lab relies on international talent to advance its mission, and IRSO's expertise is critical to our ability to bring people from other countries to work here. Currently, the lab has over 800 visa holders, none of whom would be here without our talented 3-person IRSO team. For more than 3 years, the requirements and restrictions for foreign nationals have been in a state of flux. IRSO kept their stakeholders abreast of the changing information. In recognition of the anxiety caused by these policy changes, they organized and co-hosted a webinar on visa issues with our external immigration legal firm. Berkeley Lab's foreign nationals were able to share concerns and get the answers they needed. Over the last 6 months, IRSO has dealt with increasingly restrictive visa policies. The uncertainty created by this dynamic environment was extremely disruptive to potential hiring negotiations, but IRSO offered expert advice so that hiring managers knew what their options were. As one colleague noted, IRSO quickly adapted and anticipated impacts. They were extremely effective in delivering exemplary customer service and did incredible work this year. I'd like to ask the IRSO team to join me on the virtual stage. Please join me in congratulating Larry Goh, Michael Nguyen, and Tamar Vered for their impressive contributions to the support of the lab's mission and workforce. Congratulations again, IRSO team. And now I would like to turn it over to our next presenter, Mike Woodward.
Hello again. It is my great pleasure to present the final Lifetime Achievement Award to my longtime friend and colleague, Gil Gilchrist. I have known Gil a long time, since he was organizing the first workshops on detectors for the superconducting super collider. Gil has had a long and distinguished career in particle physics, and every project he's been a part of has benefited from his excellent and insightful leadership. That's why I call on Gil to lead the effort to return people to the lab over the last few months. It's my pleasure and honor to recognize him for his pivotal contributions to particle physics research that are evident today, from the grand instruments at the Large Hadron Collider in Geneva, Switzerland, to the dark matter search experiment recently installed 1 mile below ground in Leeds, South Dakota. We're now going to go to the video and learn some more about Gil's work.
I think it would be difficult to identify someone who's made greater or more wide-ranging contributions to the high-energy physics community than Gil. And his achievements have allowed us to address key questions in and beyond the standard model.
So I knew since I was a teenager I wanted to be a particle physicist. It was just the general field that you're discovering the fundamental nature of the universe that appealed to me. As a super collider became a real entity in Texas, there was a request for developing big experiments. And one of those was called the Solenoidal Detector Collaboration, SDC. And the spokesperson for that collaboration was George Trilling. I joined with him as the technical manager, and it was the first approved large experiment at the super collider. And it took advantage of a lot of this development of detector research technology that I had been involved in. So when the SSC was terminated, there was a period of figuring out what to do. And so we joined Atlas. I took on how to design and fabricate the mechanical support structures with ideally no material in them for all of these detection elements that my colleagues were cleverly working on. We built the capability to do that, and it's now one of the most advanced in the world. And in fact is doing things for the next generation of experiments at the LHC. One of the most satisfying things was to see this whole arc of starting fundamental research and development on something that you didn't know how to do, and then you figured out how to do it, and then you figured out how to make a whole lot of it and put it in an experiment that found the Higgs boson. Gil had an unerring ability to go straight down the path to take you to an executable project without a lot of side journeys into blind alleys that aren't going to work. He's kind of a born mentor and has led the community very effectively toward promising looking technologies that hadn't really ever been fully tested out before, particularly in the collider type environment. Working with Gil was a joy.
He has very good scientific judgment. I think his ability to manage these large efforts is rare in the community. Also, the willingness to stick with it and do an extremely good job and keep all these many people happy.
After 14 years working on Atlas, one of the things that was interesting was underground experiments for dark matter. Well, the general presence of dark matter is well established. Its very nature is just unknown. So that seemed very attractive to me, to try to find something that would basically change the picture of how the universe looks and would really change how big science is done.
So congratulations, Gil. And now I would like to have Gil come on down and say a few words, if you would.
Thank you, Mike. I'd really like to thank everyone with whom I've worked over the last 30 some years at LBL. This award is only possible because of your capabilities and hard work. So again, thank you very much. And I look forward to meeting you all in person sometime in the future. Thank you.
And thank you, Gil. And now let me turn it over to Horst Simon, who will do our next award.
Good afternoon. It's my great pleasure to present the second Operations Award this afternoon. Berkeley Lab's leadership of large scientific initiatives is well known, of course, but this year we wanted to recognize the extraordinary strategic vision and outstanding work that went into the proposal that ultimately led to the National Water Alliance for Water Innovation, NAVI, a $134 million 5-year award to address water security issues. As one of the team's supporters writes, it was a monumental undertaking, bringing together 35 members and over 180 organizations, required coordination and close cooperation across multiple organizational boundaries, business models, and regulations. The number and variety of stakeholders meant that there were few precedents for engagement on such a scale. The team dealt with a wide range of challenges and often met them with creative and innovative solutions, from complex contractual agreements to a tailored IP plan to leveraging existing relationships with California agencies and state officials. Not only did this team provide capable of pulling together such an enormous and complex task, but also managed to set new standards for designing, building, and executing high-impact national R&D centers. As an industry colleague noted, the NAVI team are exceptional and truly exemplify Berkeley Lab's vision of bringing science solution to the world. And now I would like to ask Peter Fisk, Jim Hawley, Purabi Thackeray, Carol Valadeo, and Michelle Wong to join me on the virtual stage. And that means you open your video. And then I would like to say congratulations, NAVI team, and let's run a round of applause. Congratulations, Peter. Thank you for your leadership, and congratulations for the whole NAVI team. Now let me turn it over to my colleague, Steve Cavan, who will be the next presenter.
As you heard earlier today, it is in large part thanks to Alistair Mcdowell that we have such a wide variety of productive beam lines and instruments at the ALS, and a robust user program that brings people from around the world to the lab. The breadth of experiments that are conducted at the ALS are truly impressive, and we are proud of the scientific advances that are enabled by the ALS. Just as important, however, is the safety of our thousands of users. This is where this year's winners of the Award for Exceptional Achievement in Safety come in. David Malone, Sharada Ravani, Doug Taubbe, and Scott Taylor are known for their user-enabling approach. As one user described it, the ALS safety team strives to understand the requirements, why and how a certain experiment needs to be conducted, thoroughly analyzes the risks, and then develops and executes a plan for the experiment that can be performed with maximal safety. This insight-driven approach makes the ALS safety team internationally outstanding. Each member of the team brings a unique skill set in measurements, chemicals, biological samples, and logistics. Together, they successfully organize a safe environment on the ALS floor. As one user noted, without their understanding, insights, safety expertise, common sense, and cooperation, our experiments would not have been possible, and I will vouch for all that because I am still an ALS user. I want to invite the awardees to join me on the virtual stage. Please join me in congratulating David Malone, Sharada Ravani, Doug Taubbe, and Scott Taylor for their impressive and enduring efforts to keep the ALS community safe and to maintain a positive and engaging safety culture at the facility. Once again, congratulations to the team, and thank you for all that you do for the ALS. Now let me turn it over to the next presenter, for Simon again.
Thank you, Steve. It's my great pleasure and privilege to make the presentation of the second Berkeley Lab Citation today. This year's final Berkeley Lab Citation goes to my longtime colleague and friend, Kathy Yellick. Kathy joined Berkeley Lab with a dual appointment as faculty scientist in 1996, and I helped persuading her to join the lab at that time and joining NERSC. Kathy has helped steer the development and deployment of new computing software and systems that have advanced multiple scientific domains. As ALD of computing sciences for more than a decade, she helped the lab to become a global leader in scientific computing and networking, as well as computer science and applied mathematics. I hope this video will give you a sense for the breadth of her contributions.
I think what attracted me to computer science in the beginning was the idea of solving puzzles. In scientific computing, it was important for me to see that role as a way of having impact on your research outside of publishing papers, because scientific computing is not primarily about making money. What I've worked on for most of my career is how do you design programming languages and tools that make it easier to solve problems in science and in engineering and in society more broadly.
I wouldn't say this about many people, but certainly Kathy has been a key contributor to the Oscar program and pushing the Oscar program forward from her research career all the way up to when she was an ALD. She has the ability to see the whole system approach and see how things fit together and make that vision realistic to people who might not understand.
So originally, when I took over as NERSC director, computing was mostly about using it for modeling and simulation. And that still is a very important role for supercomputing and for NERSC. But these data-intensive problems combined with high-performance computers were something that I think we hadn't really started to appreciate very deeply across disciplines. I think Horst really started that when he came to the lab. But then the other person that I think was absolutely critical in that was David Brown. And when he came in to lead the computational research division, and I think through a series of projects like the CAMERA project that Jamie Sethian leads, really showed people that there are different problems. There was a lot of interest in the idea of trying to leverage our strength in computing and applied math in building new programs across the lab.
whether it was creating the scientific networking division or her advocacy for large-scale data science, for machine learning for science, for the Berkeley Quantum. Kathy was maybe at least a full cycle ahead in her own thinking on every one of those things.
The Berkeley Quantum program, to me, was just an amazing example of really thinking about a strategy that would work for Berkeley broadly. I knew we were facing the end of Moore's Law, and so this can be a game changer if we can really make quantum computing work at some scale. It's not about incrementally making this computation go 50% faster or whatever. It's, can we solve a new problem or a problem in a different way by using large-scale computing and advanced algorithms?
Kathy has done amazing research work. She developed a series of computer languages, Unified Parallel C and Titanium, and she did so many important things in parallel computing. She has had a terrific set of research accomplishments, and I think that they will be growing in the coming years. We're celebrating now, but there's more to come.
Congratulations again, Kathy. And I would like to come on the virtual stage, you to come on the stage and make some remarks, please.
Well, thank you very much for the award. It's been a real honor and privilege to work with here at the lab, and both as a scientist and as a manager at the lab. And I really feel like this award should be shared by all the people that I've worked with, the students and the postdocs and the faculty and staff on my own research projects, as well as the scientists and engineers at NERSC and CRD and in ESNet, and of course the division directors in computing sciences. So I do want to thank all of them. So Inder Manga, David Brown, Sudeep Dosanjh, as well as Jonathan Carter and Helen Kadamatori, who really worked with me to build up and expand the role of computing at the lab. It's also been a real pleasure working with Mike and his predecessors, with Paul Alvisados and with Steve Chu. And I really appreciated their support, not just for me personally, but also for working with me to see how we could use computing to connect to projects across the laboratory. And finally, I want to thank you, Horst, for hiring me as a faculty scientist when you really didn't know much about me, and for then entrusting me with, first as the director of NERSC and then as the associate laboratory director of computing sciences. You've been a great mentor and a colleague and a friend. I've had a great time working with all of you here at the lab, and I'm not done yet, as Paul said. I think there are just tremendous opportunities for all of us who are involved at the lab to bring all of our unique expertise and capabilities across the lab together in order to answer open scientific questions and in order to address the many challenges that we face in energy, the environment, and society more broadly. So thank you to everyone.
Thank you, Kathy. Thank you for all the contributions that you've made over more than 25 years to the lab. Congratulations. Let's put a round of applause out again. Now let me turn it back to Mike for his closing remarks.
Before we end, I just want to take a few minutes to thank the people who made this all work like a switch watch. First, to the nominators who put together compelling cases for the lab scientific and operations staff, to the lab recognition committee who reviewed dozens of nominations and had to make some very difficult choices, to our Career Pathways Office for flawlessly coordinating logistics and communications, to Marilyn Sargent, to the lab's videographer who produced these terrific videos and the other ones you see from the lab, and to our protocol team whose work behind the scenes kept us on track, and finally to Miles Green, who kept us all in line as our webinar maven today. Finally, to all of you who have been recognized today, you have honored us by sharing your great intellect and creativity and your dedication to the mission of the lab. These awards testify to your ability to make this lab a much better place in all of its dimensions. So we honor you and we thank your families for their support of the work you do here. So thanks and congratulations to all of you. If you would like to keep the celebration going, Miles Green, who is also an accomplished DJ, is hosting another Groove Lounge event at 5:30 this evening. I recommend it. Just tell them at the door that Mike sent you. And so now, thank you again for being with us for the virtual ceremony. I would like all of the recipients to join us here on the virtual stage, if you can, for one last look. And then we'll end this and look forward to collecting in the auditorium next year where we can do it in person. Thank you, everybody.